or you want to come to my office so we can talk. And there's some appendix do have many questions answer, but just a final answer. You want to compare the final answer, but you still need to show the details when submitting the homework. And after the homework, we'll have the exam a week after next week.
Wednesday.
Did you say
That's the current plan?
of your product didn't work? I said it wouldn't. This was I say too, but I was just making sure. I think it's their opinion.
Are we
I
gonna
feel
have
like
time to go
it's
over the
original
homework
taste
like we didn't last time, or?
Definitely, I will give you the homework back before the exam. Yeah, and also definitely I will post the homework answer after you guys give me the homework, so you can review that. Okay. Okay, so as we have explained last on Wednesday class, please review the quality discounts example on page 573 to 576. Since we don't have time to go through an example in class, but it's very important because you know that in reality, many times we will have discounts if we order more. Then in this situation, the EOQ model, the simple EOQ model, won't fit for this situation. You want to use the discounts model, quality discounts model to get the optimal order quantity. Then we have finished the big category of EOQ, so which have three models. Who can tell me what are the three models belong to the big family of EOQ?
Order discount.
Quality discount, that's right. It's not EPQ, EOQ. That's absolutely correct. So it's EOQ, EPQ, economic production quantity, especially fits for the manufacturing, and the quality discounts model. Okay, next we'll move to some more advanced model. In our class, I won't test too much about what we will mention in the next 20 minutes, except we will go some like concepts or idea. But I can say in reality, those advanced models are really the models most used for many companies. Still, many companies use EOQ, EPQ, but since they have very strong assumptions, most companies, especially companies with a lot of products, very complex order system, they will use some model we introduce today. Okay, we remember at the beginning of this chapter, for inventory management, we have to answer two questions. The first question, when to place order? When to reorder? So, reorder points is the point you set when the quantity on hand of this item drop to this level, and then it will trigger the action of reordering. So, for the simple EOQ model, you still remember? Very simple EOQ model. How to determine this reorder point? Anybody remember? For the EOQ model, how to determine the reorder points?
Reorders in like new cycle or something?
No, it's before the new cycle because that's the lead time between you place order until receive the order. Right?
Between
Okay, then you divide didn't you divide the
For EOQ.
Yeah, EOQ.
you divided the you divided Q by the production days or something?
No, that is about cycle. Aaron?
on the usage rate for your product, and you divide that by or multiply that by your lead time
That's
for your
right.
orders.
So it's usage rates times lead time. Or you can say demand rates by times lead time. So it's basically, for EOQ, since we know exactly the lead time is fixed, and then we know the exact demand usage rate because it's a fixed. And we have discussed. Those are two very strong assumptions. But let's say those are correct. Then we have say you have 10 units per day, which is your demand rate or usage rate. Lead time is 2 days. Then you know for sure it's 10 multiplied by 2 with 20 units. You should reorder it. Very obvious because these 20 units can satisfy exactly 2 days demand. And you know exactly for sure After 2 days, the new order will come. So EOQ model, we didn't answer this question because it's so trivial. Okay, you know that when to place order again. That's EOQ. EPQ is a similar or discount model. As long as the usage rate is constant, lead time is fixed, that this is formula to calculate the reorder points. But in reality, we know in many situations we can't have such strong assumption. For example, the rate of demand can be a random variable. A fluctuation is also a fixed number here. Lead time, again, sure has variation, right? If you have traffic or hurricane, flood, okay, hurricane plus flood, like last month, so in South Carolina, I-95 just doesn't work for like 2 or 3 days, right? Then you will have a longer lead time. And even we know that they are both fluctuation, but still the extent of this variability of fluctuation will affect the reorder points. The last one is what's your degree of stockout risk you can accept? Basically, is what is your target service level? Okay, is the customer important for this item? That's 98% customer service. If that's like C category, ABC rule, C category, 90%, even 85% is fine. So you can accept a higher rate of stockouts. Okay. So those factors will affect our reorder points. But for EOQ, doesn't matter too much because the first two are known and fixed. We won't count the fourth one because we'll have 100% satisfaction rate. Third one, there's no variability. So for EOQ, you can see it's very simple. But for general situation, those are all the factors we have to consider. Okay, now they use D. Okay, that's U is what we used for EPQ, but let's keep it consistent. D is the demand rates. So reorder points is the demand rates, D times lead time. Okay. And the demand rates can be per day or per week, lead time by day or by week. If that's an uncertainty, okay. Without uncertainty, this formula is enough. Very straightforward. But most likely, we will have uncertainty for either demand rates or lead time, or both. And most likely it's both have the uncertainty. Right? Then we'll have possibility that demand will be greater than the available supply or your inventory. Right? We want to reduce the likelihood of stockouts. The reason is that we don't want to disappoint our customers. Right? Then very important concept is introduced here. It's called safe stock. Has any of you heard of safe stock before? Raise your hand if you have heard of safe stock. Okay, just Aaron and Jack. So, Aaron, in your opinion, what is safe stock?
It's usually like it's mostly with a product that you like sell a lot of, or that's really important for your customers. That you keep a certain amount of it, kind of I guess like to the side, and don't include it in the inventory reorders, so that if you have someone come in and buy a lot, and you have to reorder, you have some during your lead time.
That's great. Yeah, I think most contents Aaron says definitely exactly what Indam did. Basically, you put it aside, okay, but just in very urgent situation, you have to use a safe stock. It's not like the replenishment. But in EOQ, again, we don't need a safe stock. As long as we know the usage rates, demand rates, and lead time, we don't need a safe stock. But for most situations, we need a safe stock, which is a stock having excess of expected demand due to the variable demand and the lead time. Then, now the reorder points is calculated this way. It's expected demand during the lead time plus safe stock. The first term is the same here, D times LT, but it's the expected value plus the safe stock. Here's the graph to demonstrate this safe stock. So, let's say you have a demand which is obvious, not constant. Well, it's decreasing every day your inventory level, but it's not constant demand. EOQ, we see the straight line. And your lead time in this example, lead time is fixed. Well, this is still simple, pretty simple, as long as we have fixed lead time. So your reorder point is here. Usually, your expected value is coming here to reach the value here. You don't touch the safe stock. But if your demand rate is very high during this lead time after you place the order, maybe you have to use a safe stock. That's the purpose of safe stock. Usually, you shouldn't use safe stock. Okay, but sometimes you have to use. Sometimes even safe stock is not enough. Okay, so that's the purpose of safe stock. And if you carry more safe stock, definitely, okay, then you will improve your customer service level. And the customer service level we have introduced, if you still remember, maybe 2 weeks ago at the beginning of this chapter, is the 100% minus stock out risk, which means it's the percentage you can satisfy your customers' demand requirements. That's safe stock. Service level. Okay. Come back to this one. Well, we spent probably less than 10 minutes on introduce the safe stock idea, and it's pretty straightforward. But I can tell you, to calculate this is not so simple. In the textbook, there are several models I've introduced this. I can tell you in advance, don't worry about that. There's no question in homework or exam will touch these models. But yeah, there's several models about that. But there's in our second case study, there are 1 or 2 groups will touch these models. Yeah, but then you can explore by yourself. What I can say, they are so useful. Even we don't have time, or so we don't have time, it's not required for undergraduate level for introduce how to calculate safe stock. But in MBA course, I do require my students several different very complex models to calculate safe stock. But I want to say this is so important. This is widely used in that industry. When I work as a consultant, we provide the optimization of inventory for our clients. All clients we use is safe stock model. None of them use EOQ. If they want to use EOQ, they won't pay us to do that because it's so straightforward, right? But safe stock is so complex. But it can handle the variation of lead time and the demand rates, which is exactly happen in our daily life. Right? Lead time is not fixed. Demand rates is not fixed. Then we should use safe stock. So if you have time, please read in the textbook, or one group will be assigned the case study later, next month, to learn more about the safe stock. Okay, any question before I can move on? The good news is it won't be tested. That's for sure. Okay, how much to order? But you should learn by yourself if you have time. How much to order? The second question, right? First question, when to place order? So reorder point. The second question is how much? EOQ again, we answer this question, right? That's the reason we calculate the Q. Okay, that's how much to order. EPQ the same, right? Discount model we also know. But generally speaking, it's not easy to answer these questions. And by the definition, there's several models to answer this question. First model is the fixed order interval model, which means, okay, it's a very traditional model. That means, okay, you place order like every Monday or the first day of every month. So that means your interval is fixed between 2 orders. Okay. EOQ, UPQ, they can belong to this fixed interval model too. Right? There's several reasons. Even if it's a pretty traditional model, still many stores, many companies use this model. There's several reasons. First one can be supplies problem. Supplier say, okay, I only have the rental cars or rental trucks on each Monday. Second, I only signed my product to place on each Monday. Then you should place the order on Monday. Even if you place on Tuesday, you have to wait 6 days. Next Monday, I will have a truck to send to you. Right? So that's why it's encouraged to use the fixed order interval model. The second reason can be group order. Right? So if I have so many retailer stores, you place order on Monday, you place on Tuesday, some place order on Sunday. It's really hard for me to handle. I have to handle order every day. I would rather that's okay, concentrate on 4 hours, receive all orders, and then to plan them. That's easy for the supplier. Some other reasons don't lend themselves to continuous monitor inventory position. If you don't have the IT system to manage your inventory, you maybe can only count at the end of Sunday, and then you know how much I have. Then I can see whether I can satisfy your order. So that's it. So that's why we say this is pretty traditional model. Okay. Any other reasons, in your opinion, why this fixed order interval model is still popular? Beyond this?
Maybe just people aren't getting more efficient with how they do inventory.
Definitely, because you want to concentrate on 1 or 2 days, not every day. Good reason. What else? Talk about a lot about supplier, right? But if you are not supplier, let's say you are a retailer store, you also maybe have some constraints. You say, that's Monday, that's only I have time to place the order. I don't have time to dealing with order on Monday. Tuesday I have the on-sites with my clients. Wednesday I have some internal meeting. So that can be another reason why even you are a retailer store, you want to place order in a fixed day, every week or every month. Another reason is for discounts. You think about that, if everybody places order on Monday, then even the supplier say, I can send you trucks or every day, any day. But if you have 3 different small retailer place order in the same day, you can get a group discounts, right? That can be a strategy. But if you want to place order on Monday and Tuesday, probably you won't get any discounts. So that's another reason they use that. In your opinion, is there any problem for this model? Fixed order interval model?
Doesn't give you the opportunity to scale for scalability at all.
So it's a good reason. That's all.
No, it's bad. It's like if there's a situation that comes up, say if you order every Monday, but say it's a big week and you need something for that Saturday, then
That's right. You have to wait.
Yeah.
And then your customer are disappointed, basically, right?
Right.
Because you have stock outs in the middle of the week, then you have to wait until the next Monday to place order again. So basically, it has that's a strict constraint on yourself for this reason. Right? You can't place, well, maybe there's some emergency order, but generally speaking, you can't order in any time between the interval, okay, or very high cost if you want to order between the interval. Then nowadays, this is a demand change dramatically, so this model can have this huge disadvantage. So, but this model is still widely used. First, I can tell you, for my clients, Unilever and Procter & Gamble, this level, I never see any clients, at least for most of their products, in North America, especially US, they don't use this model. But Unilever, let's just talk about Unilever. Okay, North America, they don't use this model, but India, many products in India, they use this model. The reason have we discussed, right? There are several, maybe the Indian supplier, they have constraints, whatever reason, but they use this model. They use a fixed order interval model. But in United States, most advanced company, they won't use this model. They will use the model we have discussed here, safe stock model. Okay, to get the reorder points, here's a reorder point, right? Anytime you touch this reorder point, I place the order. I don't care if it's Monday, Tuesday, even Saturday evening. Okay, it's your inventory level. Okay, trigger this point, and it will trigger the action to place the order automatically. Right? Automatically place the order, send this invoice requirement to our supplier even on Sunday evening, right? And then this method is, I would say this method is more reasonable in current situation, given the demand rates has a high fluctuation. Right? But as we discussed, this is very simple. When you place order every Monday, well, you don't need to worry about inventory. Since you worry about it, doesn't work. Right? Even you say, okay, inventory is out of stock, you have to wait on Monday. So it has some advantage. But just remember that here is the model we should go if we have the ability to go. Right? Reorder points. Continue to track our inventory level and set the reorder points by using the formula, then place order whenever we need to place order. Don't wait. Okay, another one is the fixed quantity model. Again, EOQ you can also think as a fixed quantity model because it's the fixed quantity Q. Okay, fixed quantity model is that way. Okay, no matter when you place the order, okay, as long as you trigger our action the reorder points, I will place the same order quantity. This is more popular. This is more popular model. This will have a higher customer service level, but the order quantity is the same. Okay, that should calculate by very complex algorithm to calculate order quantity. And what I can say is that in reality, in United States, most company kind of go to fixed quantity model than fixed interval model because we have the IT infrastructure in United States. We can monitor our inventory level continuously. Okay, we can easily has this action. Once it's come to our reorder point, we place the order. And this order quantity usually is fixed, but sometimes it can change. For example, Christmas, Thanksgiving will come very soon, right? At this time, you should increase your order quantity. But generally speaking, you should use these reorder points to trigger your action of reordering instead of wait for next Monday to do that. That's a better way and to save your costs if you go to this model. Okay. So in fact, I only spent 20 minutes on these past 5 slides, but I can tell you, probably you have to spend 1 or 2 semesters if you really want to go to the detail on this from safe stock model and fixed order interval or fixed order quantity model. Because they are much more complex than EOQ, EPQ, but they are widely used in industry. Okay, if you go to MBA course, operation management or supply chain management, most likely you will learn that. Okay, anyway, let's move on to our last model, which will be definitely tested in your homework and also exam. Also very important model, which is a single period model. Single period model, by definition, model for ordering of perishables and other items which has limited useful lives. Give me some examples. Well, what are the products, in your opinion, you know that are perishable or has limited useful lives?
Produce,
That's cool. What else?
dairy,
Dairy.
frozen
Dairy,
food.
definitely. You can go all the grocery. That's
I work.
Oh, let's exclude grocery. Let's exclude grocery because you can say whatever chicken, beef, pork, fish, seafood, especially, right? There are lots. Let's export whatever we can eat. Think about the other thing.
Perfume.
Huh?
Perfume.
Oh, that's great. Fortunately, we still have 2 girls in our class. Otherwise, food just concentrate on food, right? So, perfumes. Yeah, that's definitely. What else?
Toiletries, like toilet paper, paper towels, and stuff.
Wait. Yeah, every product has an expiration date, but I think toilet paper expiration date is very long, right?
Oh, is that just like perish? Okay.
Yeah, it's not so. Yeah, if you say the interval is very long, everything is perishable. And human beings, unfortunately, we are perishable, right? But yeah, we want to see some products really like in short term, daily, 1 day, 2 days, 3 days, or 1 week, something like that. Toilet paper, I would say, is not so perishable.
Mouthwash and toothpaste.
Huh?
Mouthwash and toothpaste.
Can be. A lot of seasonal products are, it's not perishable, but it has limited use time, right?
Pumpkins.
Huh? Pumpkins, that's right. Yeah. Right? It's not, because the pumpkins we use in Halloween, as far as I know, right? It's not eatable, or at least nobody will eat the pumpkins, right? So after Halloween, you won't eat these pumpkins and it's not useful. You can't be sustained until next Halloween, right? So you can think about it has limited life cycle. Very good example. What else? A lot of seasonal
Clothes.
Huh?
Clothes.
Clothes. What type of clothes?
Like, well, like playoff clothes right now.
Very good example. Very good example.
As soon as the playoffs are done, nobody's gonna
Yeah.
get it.
NCAA champions, right? Or Super Bowl champions, this clothes is just like really limited time lifetime. So if we consider the inventory model for these perishable or limited life cycle products, we should consider single period model. Since the reason that we don't need to consider like 1 week later or 1 month later's inventory level because we want not use this product, they are not useful for us. So that's a traditional name for this single period model. It's called a newsboy model. Okay, you can think about newspaper. It's a very traditionally products with limited useful life. Usually it's a daily life. Even it's less than 1 day. Maybe only morning or 4 hours, 8 hours. Then nobody will buy the newspaper in the evening, even in the evening, no matter tomorrow or later. So if you are a newsboy, let's say you sell a Wall Street Journal in the streets of Manhattan, that's your work. That's your job, right? Every day, every morning, you order the Wall Street Journal, and then you stand on the street of Manhattan, let's say Fifth Avenue. You want to sell all your Wall Street Journals to the readers. Then this is a very big decision for you for your daily life. You have to determine how many new Wall Street Journal you want to order every day because you know the leftover Wall Street Journal is useless for tomorrow. Nobody cares about yesterday Dow Jones Index, right? Who cares? What we care is today's, right? So that's a very critical decision for you. So newsboy, if you are a newsboy, you have to determine how many you want to order. Then if you are a newsboy, you have 2 costs you have to consider. The first one is the shortage cost. Generally speaking, if you only order 100 Wall Street Journal, and then the 200 customer really wants to buy Wall Street Journal from you today, then you lose the customers. You lose the unrealized profit, which is easy to calculate, which is the revenue per unit per Wall Street Journal minus the cost. Let's say you order that's like 50 cents. Okay, you sell them by $1. Then per unit you lose 50 cents, which is unrealized profit, the shortage cost. The selling cost, easy to understand. If you have more than enough Wall Street Journal on hand, by the end of the day, they're useless. You have to throw them in the trash can, maybe recycle them, but you have, let's say you have 0 left over, or very little left over. So the excess cost is the cost per unit, is the ordering cost, 50 cents, minus the salvage value. If you can give it to the recycle place, maybe 10 cents per newspaper, as most you can get. Okay, that's your excess cost. So it's a trade-off. You don't want to order too many, right? Which will have an excess cost, or you don't want to order too little because then you will have the shortage cost. So for this newsboy, every morning he or she has to make this critical decision for his or her life. Okay, how many to order? It seems easy, but you consider the stock, okay, markets change dramatically, the weather condition. It's not easy, in fact, for the newsboy to optimize his or her inventory model. That's why we are introducing here. Clear for you, the background of this single period model? Great. Okay, so the goal of this newsboy model or single period model is to identify the optimal order quantity which will minimize the long run excess and the shortage cost. There are 2 categories we'll consider in this model. The first one is the demand follow a continuous distribution. For example, like a normal distribution, exponential distribution, that's a continuous distribution. The second one is demand follow a discrete distribution. Okay. Anybody can give me some example of discrete distribution? Nobody remember? Discrete distribution. Now you are only known as normal distribution. But there's some distribution not continuous, not normal.
T distribution.
T distribution, you mean the T value?
Yeah,
T value is in fact, I believe T value for the If you run the statistics like regression, have t-value, this follow the gamma distribution. If my memory is correct. It's continuous.
Bell shape.
Bell shape is continuous distribution, right?
Bell shape's normal.
Huh?
Bell shape, that's normal, right?
Yeah.
Normal distribution.
Bell shape is normal distribution. It's just a different name. They have normal distribution have lots of different names. Maybe you can give an example of a discrete distribution. You don't need to know the name as an example. Okay. You toss a coin. Right? That's a random event. You toss a coin. There are only two outcomes. What are the two outcomes?
Head or tail.
Yeah, right? That's a distribution. 50% should be 50%, but you can have research show it's not 50% because there's a weight. But let's say 50% head, 50% tail. What's the distribution name of this one?
100%.
Binomial
That's right.
distribution?
Bernoulli distribution. So maybe you remember, I believe you learned that from business statistics 1. So there's some distribution like toss your coin and some other distribution follow that's distribution. For example, another thing is that you will have student here. Final grade is A, B, C, D. It's a discrete distribution. It's not continuous because there's nothing between B plus and A minus. Jump from B plus to A minus. If they have limited outcome, that is the discrete distribution. Right? Because normal distribution we have continuous outcome. Well, think about these two categories for this single period model. So to calculate our optimal inventory or ordering quantity, first we have to calculate the optimal service level. Since we know service level will determine our inventory level. So how to calculate that? Optimal service level is equal to CS, which is the, what's CS? Shortage cost. Great, Branko. Divided by CS plus CE. What does CE mean? Excess cost. Great. So, and then you will determine this optimal stock level. Optimal service level. Then, based on the distribution, for example, if we follow normal distribution, let's say your optimal service level is 95%. I think you guys already have experience how to find the Z value, right? From chapter 10, you have experience. You go to the table, you go to the appendix, 95%, okay, then what is the Z value correspond to 95%? You will find that. I believe it's 1.64, something like that.
645.
1.645. Oh, 645. Great. Yeah. So then you can guess the value you should order. Right. This is the order quantity. Okay, let's go through an example. Then you can easily understand about this model. So first, let's rewrite this formula for you. Otherwise, some students may forget the formula. It's very simple formula. So your customer service level. This is optimal customer service level. Okay. Again, we use calculus to prove this is optimal. Well, we don't require here, so just need to remember this formula. And then we can determine the optimal stock level. So sweet cider is delivered weekly to Cindy's cider bar. Demand varies uniformly. So which means this is the discrete distribution or continuous distribution? Continuous. Great. It's uniform between 400 liters and 600 liters per week. Cindy pays 20 cents per liter for the cider and charge 80 cents per liter for it. And unsold cider has no salvage value and cannot be carried over into the next week due to the spoilage. Want to find the optimal stocking level and its stock out risk for that quantity. First, stock out risk. How to calculate stock out risk? What's the relationship between stock out risk and the service level? 100%, just minus, right? So 100% minus service level. So make this clear. Okay, next we have to figure out something. For example, to calculate CSCE, we have to figure out something. If you CS is the revenue minus the cost. So CS revenue minus cost. CE is equal to cost minus salvage. Right. Okay. I think we have enough hints. Then now you can begin to solve this first part of the question.
So, which one do you pay? Like, between 400 and 600? What do you say?
That's the uniform distribution.
Okay. Okay.
It says there's no salvage, so.
That's right. That's right.
Let's see.
Doesn't vary. Goes down the same rate. Each week it's the same.
Honeycomb. So CS, what is how do you calculate CS? Revenue, what is revenue? Revenue per unit. When Cindy sell the cider, how much she can get?
8 cents.
Yes. So revenue 80 cents, right? What is the cost?
20.
Yeah.
So,
What I'm saying, right?
so if it's sold between 400 and 600 units,
Would it be 5? Let me take that.
the average, that would be 5.
Because I don't know if we started staying off. Because I was about to do 400 minus 80 and then 600 minus 20 or vice versa, you know.
Yeah. Cindy pays 20 cents per liter for the cider.
So percentage?
It's 8 cents per liter for it.
Yeah, that's right. But you have
Oh,
to
it would
answer
be,
the first
okay, so it would be
part.
8 cents. So 400 or 600 times 80 cents. I'm just trying to figure out maybe 500. Should you
Mm-hmm.
Maybe 32,000.
Revenue is the selling price, right? Per unit. So revenue per unit is the
$3,200 per liter. It's 20 cents.
Okay, so what we started
Have you calculated service level? First, you have to calculate service level, and then you can worry about the distribution. First, you calculate and figure out the service level. What is CS? Right.
Sure.
How do you calculate that?
C minus the price.
And what is the revenue? Revenue minus price, right? Revenue is equal to what?
Get CE.
The revenue, she charges 80 and she pays 61.
Revenue is 80 cents,
Oh, yeah.
right? 80 cents per liter. Okay, 80 cents minus 20
So
cents.
when you
Right?
subtract
Yeah.
that,
60.
Okay.
Similar.
You also have to do the second.
60 over 60 plus, C would be the excess. So the excess would be 20. Right?
CS, yeah, 60, yeah. Then you need to calculate CE, what is CE?
Yeah.
From the revenue,
How did you get your
60 over 60.
Yeah, that's it. Yeah. I know it was right.
try to put in decimal
Nice,
points.
40 cents. It's, CS, you like that, it's 6 cents, right? No, it's not 60.
It's 40 cents.
It's 80, right? 80 minus 20. Selling price is 80 cents.
Yeah, but the revenue is what
Revenue is your selling price. 6 is your profit. You double subtract 20 cents. When you get 60, you already subtract 20, right?
I thought we were doing the revenue would be 60 cents because 80 cents is how much you're charging and 20 cents is how much you're paying for it.
Okay, Econ 101. Definition of revenue. Revenue is whatever you can get from customer without considering cost. When you subtract the cost, which means your profits.
What?
Right? Agree with me?
Oh my
So
gosh.
6 that's your profit.
It's about to be crazy.
Not your revenue. Revenue is that no matter you buy for this phone like $100 or $200, you resell it by $300. That's a fixed $300
But it's not
revenue.
gonna finish over tonight.
So this
So I'm gonna get up late, 8 o'clock.
Yeah.
So I'm in the library all
So then
day.
your the
man.
rate would be 25.
Yeah, stock outreach is easy. That's the first
That's
part,
Friday,
the hard
too.
part.
So this is this in cents or
I got
percent?
exams next week too.
So this 0.75 is
Oh, yeah. It's crazy, man.
It's your customer service, which means like 3/3 of a customer can guess whatever they want. 25%
okay.
of
So
customer.
this is a percentage.
This percentage.
So this is 75%.
Yeah. You should explain. You can use the decimal number, but you should explain by percentage.
Your service level.
But the hard part is the first one.
And then
To optimal stock level.
so it'd be by 300 times 8.
Okay, I have seen
Or
many
300
students have
times
finished
20.
part 1. So, who can tell me what is the optimal service level in this example? Any volunteer?
Is it in cents or is it?
So it's which is 80 minus 20, which is 6 cents, right? For the shorting cost divided by 60 plus 20, which because excess cost is 20 minus 0, we have 0 salvage value. So you get 75%, which is your customer service level. Great, thank you, Christine. And then your stock out risk is very easy to calculate, 25%. So the hard part for this question is optimal stocking level. Any volunteer? Optimal stocking level. Who, tell me your answer, then I can tell you what is correct.
Is that part B that you're talking about?
No. Find the optimal stocking level.
What is CE not 80? Shit.
Anybody guess that? Optimal stocking level? No? We have used the distribution to calculate optimal stock level.
There's no salvage, right?
Yeah,
Yeah, there's no salvage. What's your question?
Cost is 0.2.
What's your question? Jacob.
Never mind, I see what you're saying. I get it now.
Okay, great.
I was just making sure the cost.
Yeah, this is the excess cost is 20 cents because there's no salvage. It's just a cost 20 cents minus 0. Okay. Anybody guess the solution of the optimal stock level?
They charge for that.
You have to use it 25% or 75%?
Good question. But what's the result you get first, Frank?
I
Do you have another? Okay.
I mean, I
Usually use
I
75%.
did cost like 80 to 120 and then revenue 320 to towards 80.
Mhm.
I don't know which percentage.
Oh, it's because of the stock out risk.
Okay, then I can solve this for you. I still want to double check. Anybody? Have you guys guessed the stock level? No?
Yeah.
No?
So is the service level the same thing as the stocking
It's just
level?
100 minus 75.
It will determine, we'll explain that. It will determine or
Okay.
affects the stock level. Because if you want to have the 75% service level, you have to hold your stock. Extreme case, you hold 0. That's your service level is 0, right? Because nobody can guess anything. If you hold more than 600, right? Because it's 400 to 600. If you hold more than 600 liters, you get 100% service level for sure. Because you know your demand, maximal value of demand is 600 liters. If you have stock level more than 600 liters, every customer will get whatever they want. Agree with me? Because maximal demand is 600. You hold, let's say, 1,000 liters. You have more than enough. Now, your target service level is 75%. And we calculate is optimal. Then, under this 75% service level, what should be your stocking level?
75% of 600?
75% times what? 600?
The average is 600, 400.
And
Is this for the second part? It'd be 300, right?
it's very close. But it's not just direct 600.
Is it 600?
600.
Like, is it the average of 600 and 400?
No, this 400 to 600 is a uniform distribution. What does uniform distribution mean?
It's the same.
No, it's the same. No, it's the same. Okay, sorry about that. Uniform distribution. Anybody can explain to Jack what does uniform distribution mean? For 600 to 400 to 600. Nobody remember uniform distribution?
Left tail is 400, right tail is 600.
That's right, but what's the distribution? Which means we have equal probability to realize demand by 600, 601, 602 until 600. 400, 401, 402 until 600. So they have exact same probability for every single point in this interval. So that's uniform distribution. Now the question is, what is the point? We have this 75 percentile.
500.
No. Who can tell Branko if we have 500, what is the customer service level? If you only have 500, it's in the middle of 400, 600, then what is customer service level? 50%.
Yeah.
Right.
Yeah.
Right. You are satisfied half of customer. Half of time, your demand is less than 500. You have satisfied order, but other time you can't satisfy that. Then, how to do that? Stock level. Alright, but I still need somebody to explain to us.
Bless you.
Appreciate it.
Do you agree with me? What I have written here?
Yeah.
That's what
That wasn't very hard.
And what is the result? What is the result? Equal to what?
450.
Uh-huh.
Oh, wait, no. Never mind. I don't know.
550.
550. Okay. Anybody can explain that to us?
Go ahead, Jerry.
Don't trust me. Trust yourself. Until you can come with that.
There's
Got
200.
multiply that 600%.
There's a difference of 200, so you need to figure out 75% of that difference.
Right?
That makes sense.
Anybody guess what Ryan said? I guess that.
Oh, yeah.
Yeah, I hope you also. So basically speaking, as Ryan said, so we can't direct you 600 because 600 is the maximum boundary of this uniform distribution. So the interval of this uniform distribution, in fact, is only 200. It's 600 minus 400, right? So in this 200 of this interval, what is the percentile? 75%. So it's 150, right? 150 is the 75 percentile for this 200 interval. But the lowest point of this uniform distribution is 400. So with 400 plus this 150, you guys 550, which is 75 percentile for this uniform distribution from 400 to 600. And we know for sure, if your stock level is 550, which means 75%, okay, your demand is less than 550, satisfy all the customers. But there are 25% stock out, right? Your demand is greater than 550 because you follow normal distribution. Then you can't satisfy your customer demand. That's how we guess that. Clear?
Yeah.
Everybody? Great. So we still have one part left for the next week. Okay, we'll see you guys on next Monday.
Like the other two models that you showed that were complicated stuff, those are not related.